Today, I will show you the procedure for multiple regression analysis that you can use in practice. Hi, this is Mike Negami, Lean Sigma Black Belt. This episode is the third video of the regression analysis series, which is very useful in business, and this is about multiple regression analysis. The previous two videos are the basics and will be the foundation for today's content, so please watch them from the link above if you haven't done so. This will be a short review from the previous video. Regression analysis is finding a regression equation to calculate the objective variable y. In the equation, the x's are called explanatory variables. When there is only one explanatory variable, it's a simple regression analysis. When there are multiple, it's a multiple regression analysis. In practice, we perform a regression analysis for sales forecasting or marketing analysis, etc. But it's rare to have only one explanatory variable, so we usually use multiple regression analysis. Fortunately, its operation in Excel is the same as the simple regression analysis. However, when preparing source data, multiple regression analysis has a couple of things you should be aware of. I will also explain the multiple regression analysis using my blog site econoshift.com as an example. These days, website management requires certain tactics to increase traffic from Google. Those traffics are called SEO. In SEO, it's essential to set target keywords for each page of a website, so I always have trouble choosing the best one. This is the SEO tool I made. The numbers in column R are the clicks to page that came from Google to each page of my blog site. If you click on target keywords in column AJ, you can see actual search keywords that were used when they came to the page. There are also various data for the keyword. I would like to know which of these data are the most important for selecting target keywords using a multiple regression analysis. In multiple regression analysis, the most important and difficult thing is to decide the objective variable and the explanatory variables effectively. In our example, our goal is to gain more traffic from Google, so I chose the clicks to page as an objective variable. The explanatory variables are selected target keywords, clicks, impressions, CTR, and position. Although I will not explain the details of SEO today, among those keyword data, I will find which one influences the clicks to page most with the multiple regression analysis. In our case, the data to be set as the objective variable was obvious, but there are cases when there are several choices. If so, it will be easier to decide by considering what you want to accomplish from the analysis results. There are also times when you have many data to use as explanatory variables. However, if you include too many of them, the accuracy of the analysis will fall. So generally speaking, have up to 7 explanatory variables at most. When you select explanatory variables, there are a couple of things to consider. Continuous data such as length and time are called quantitative data. On the other hand, data such as male, female, and like-dislike are called qualitative data. These data are always included in survey results. You can use those data in multiple regression analysis too, but they need to be quantified. You can apply numbers like 1 for male, 2 for female, or 3 for like, 2 for neutral, 1 for dislike, and so on. This variable is called dummy variables. Here is another consideration. During multiple regression analysis, if you use data with high correlation among explanatory variables, we know that mathematically it's not possible to obtain a correct regression equation. We say that there is multicollinearity. In a frequently used example, when you do multiple regression analysis with people's height as objective variable and the length of right and left legs as explanatory variables, you'll get a funny result like this. The left leg's coefficient is minus, which means that the longer it becomes, the lower the height becomes. To prevent multicollinearity, first calculate all of the coefficient of correlations between all explanatory variables. If there is a group of data with strong correlation, exclude one of them. Or, for some reason, if you need to include both, merge them as one group of data in an appropriate way, such as averaging them. Let's do it on Excel. Here are explanatory variable data. Excel has the call function. By selecting two data ranges you want to compare in the call function, it will show the coefficient of correlation between the two data groups. I confirmed that there are no high coefficient of correlation this time, so I'll use all of the data as explanatory objectives. Let's do a multiple regression analysis now. Select data, data analysis, then regression. In the input Y range, select the range of the objective variable, which is click to page. In the input X range, select the entire explanatory variable's data range. For multiple regression analysis, you should include each column names and check labels here. As a result, the column names of your explanatory variables will appear in the regression result. I explained the p-value in the previous video in detail. Please watch it. Briefly, explanatory variables with lower p-values have stronger relationships with the objective variable. In our case, it turned out that statistically, the impression of such keywords affects the clicks to page most. It was great to explain this logically. From these coefficients, my multiple regression equation looks like this. Now I can predict the clicks to page from my target keywords data. The adjusted R-square is 66%, so it is a reasonable result. The best result in this analysis for me was to find that impression is the most important factor when deciding my target keyword. This is very helpful for my SEO activities. Thank you very much for viewing. Please click the subscribe button. Also click and watch my other related videos. Thanks.